Hello, I'm Professor von Schmohawk, and welcome to YU. In the previous lecture, we saw how to add or subtract fractions with different denominators by creating a common denominator. We saw that the easiest way to do this is to multiply each denominator by the denominator of the other fraction. However, sometimes this creates an unnecessarily large common denominator. We will see in this lecture how to find the smallest possible common denominator, otherwise known as the least common denominator. Prime factorization is the key to finding the least common denominator of two or more fractions. Recall from our lecture on factoring that this involves finding all the prime numbers which, when multiplied together, produce the number that we wish to factor. Prime factorization allows us to break down each denominator into its basic building blocks of prime factors so that we can see how to create the smallest possible common denominator. As an example, let's say that we want to add 1/6 and 1/30. We must make the denominators of these fractions the same so that we can add their numerators. If we factor each denominator, we can write each of them as a product of prime numbers. Since our goal is to make these two denominators the same, let's see what is making them different. The first denominator is missing one factor of 5 that the second denominator has. We can remedy this situation by multiplying the numerator and denominator of the first fraction by 5. This doesn't change the value of the fraction since it's the same as multiplying the entire fraction by 1. However, its denominator will gain the additional factor of 5 that it needs. The two fractions will then have a common denominator of 30. This is the smallest denominator that will work for both fractions, so it is the least common denominator. Now, adding the two numerators, we get the sum of 6/30. As another example, let's say that we wish to add 1/6 plus 1/18. We first factor each denominator. The first denominator has only one factor of 3, while the second denominator has 2. We can make the two denominators the same by multiplying the top and bottom of the first fraction by 3. The two fractions will then have a common denominator of 18, which is their least common denominator. And we can now add their numerators. Let's try another example, adding 1/30 plus 1/42. Factoring each denominator, we see that the first denominator needs a factor of 7 that the second denominator has, and the second denominator needs a factor of 5 that the first denominator has. So we multiply the top and bottom of the first fraction by 7, and the top and the bottom of the second fraction by 5. The two fractions now have a least common denominator of 210, and we can now add their numerators. To see the advantage of using the least common denominator, let's take the example we looked at in the beginning of the lecture, 7/12 plus 5/18, and find a common denominator as we did in the previous lecture, multiplying the top and bottom of each fraction by the other fraction's denominator. Using this technique, we end up with a common denominator of 216 and a sum of 186 216ths. Now let's try it again using the least common denominator. We'll start with the same fractions and factor the denominators. Now we can see that the first denominator only needs an additional factor of 3, and the second denominator only needs an additional factor of 2. So we end up with a much smaller common denominator of 36 and a sum of 31/36, which is a lot simpler than the result we obtained by multiplying the two denominators. The power of using the least common denominator is especially apparent when we add or subtract more than two fractions. For example, let's calculate 3/8 plus 1/6 minus 5/12. We first factor each denominator. We can see that to make these denominators the same, we need to add a factor of 3 to the first denominator, 2 factors of 2 to the second denominator, and 1 factor of 2 to the third denominator. This gives us a least common denominator of 24 and a total of 3/24. We can see that in order to add or subtract fractions with different denominators, we need to create a common denominator. We have also seen that these calculations can sometimes be greatly simplified if we use the least common denominator. However, even when we use the least common denominator, the result of our addition or subtraction may be a fraction that can still be written in a simpler form. In the next lecture, we will see how to convert any fraction to its simplest form.